Myself, BL Deepan, HOD Electronics, गवर्नमेंट पॉलिटेक्निक कॉलेज जोधपुर। प्रीवियस क्लास में हमने स्टडी किया था डिफ्यूजन एंड ड्रिफ्ट करंट्स इन ए सेमीकंडक्टर। इसी टॉपिक को आगे बढ़ाते हुए टुडे वी विल डिस्कस अबाउट ड्रिफ्ट करंट इन ए सेमीकंडक्टर। ड्रिफ्ट करंट, द फ्लो ऑफ चार्ज कैरियर्स which is due to the applied voltage or electric field is called drift current। यानी किसी सेमीकंडक्टर के अक्रॉस वोल्टेज या इलेक्ट्रिक फील्ड अप्लाई करने पर चार्ज कैरियर्स का जो मूवमेंट होता है, उस मूवमेंट के कारण जो करंट बनती है, दैट करंट इज कॉल्ड एज ड्रिफ्ट करंट। इन ए सेमीकंडक्टर देयर आर टू टाइप्स ऑफ चार्ज कैरियर्स। जैसा कि हम जानते हैं कि सेमीकंडक्टर में देयर आर टू टाइप्स ऑफ चार्ज कैरियर्स, इलेक्ट्रॉन्स एंड होल्स। They can contribute in current. They are electrons and holes. When the voltage is applied to a semiconductor, the free electrons move towards the positive terminal of a battery and holes move towards the negative terminal of the battery. Voltage apply करने पर सेमीकंडक्टर के अक्रॉस इलेक्ट्रॉन्स जो है, फ्री इलेक्ट्रॉन्स पॉजिटिव टर्मिनल ऑफ द बैटरी के तरफ अट्रैक्ट होंगे and holes move towards the negative terminal. Holes negative terminal की तरफ attract होंगे. Electrons are the negatively charged particles and holes are the positively charged particles. And charge on both the particles is the same. As we know that like charges repel each other and unlike charges attract each other. Hence the electrons negatively charged particles are attracted towards the positive terminal of a battery and holes positively charged particle are attracted towards the negative terminal. जैसा कि इस डायग्राम में शो किया गया है कि इलेक्ट्रॉन्स आर मूविंग फ्रॉम राइट टू लेफ्ट towards the positive terminal of the battery. Holes are moving from left to right towards negative terminal of the battery. But holes can move up to the end of the semiconductor bar, where at the end of the semiconductor bar or semiconductor piece, these holes are neutralized by these holes recombine with the electrons coming from negative terminal of the battery, and here the holes disappears. In a semiconductor, the electrons always try to move in a straight line towards the positive terminal of the battery. But due to continuous collision with the atoms, they change the direction of the flow. Each time the electron strikes an atom, it bounces back in a random direction. Electrons अपने movement के दौरान बीच में atoms के साथ में interact करता है, electrons के साथ में atoms के साथ में collide करता है, और उसके कारण उसकी डायरेक्शन जो है वो स्ट्रेट लाइन नहीं होकर कुछ जिगजैग मैनर में हो जाती है. The applied voltage does not stop the collision and random motion of the electron, but it causes the electrons to drift towards the positive terminal. But ultimately, electrons will drift towards the positive terminal of the battery. The average velocity that an electron or hole achieved due to the applied voltage और इलेक्ट्रिक फील्ड इज कॉल्ड ड्रिफ्ट वेलोसिटी. तो इलेक्ट्रॉन्स या होल्स का जो जिगजैग मोशन हो रहा है या रैंडम मोशन हो रहा है, उसकी जो वेलोसिटी है, एवरेज वेलोसिटी है, दैट वेलोसिटी इज कॉल्ड एज ड्रिफ्ट वेलोसिटी. सो सेमीकंडक्टर बार में होल्स और इलेक्ट्रॉन्स का मोशन शो किया गया है. होल्स आर मूविंग टुवर्ड्स नेगेटिव टर्मिनल ऑफ द बैटरी and electrons are moving towards positive terminal of the battery. Holes का जो movement है within the semiconductor limited रहेगा, whereas electrons can move away from the semiconductor bar also. Electrons can flow in conducting path also. Drift velocity of electrons is given by Vn is equal to mu n e, यानी कि drift velocity is proportional to the applied electric field. अगर आप applied electric field ज्यादा होगा, in that case drift velocity will be more. In this equation, Vn is the drift velocity of the electrons, E is the applied electric field, its unit is volt per meter, and mu n is the mobility of the electrons. Similarly, for holes, we can give expression of drift velocity. Vp is equal to mu p E. Vn is the drift velocity of electrons, Vp is the drift velocity of holes, mu n is the mobility of electrons, mu p is the mobility of holes, and E is the applied electric field. Therefore, the drift current density due to the free electrons is given by, हम जानते हैं कि J is equal to QNV होता है, QNV, where Q here it is equal to E, or E is the charge of the electron or charge of the hole. N is the concentration of charge carriers. N may be replaced by P in case of holes. Mu n is the mobility of electrons and E is the applied electric field. Therefore, drift current density due to free electrons is given by Jn is equal to E n mu n E. Similarly, for holes, the expression for drift current density is given by Jp is equal to EP mu Pe, where is the electronic charge or hole charge, which is equal to 1.6 into 10 to the power minus 19 coulomb. P is the charge carrier concentration in that semiconductor specimen. Mu P is the mobility of the holes, and is the electric field applied. The total drift current density is given by J is equal to Jn plus Jp. Therefore, J is equal to En mu n E plus Ep mu Pe. J is further equal to E bracket n mu n plus P mu P bracket close E. This is the final expression of a drift velocity, a drift current density in a semiconductor due to electrons as well as holes. Electrons and holes mobility. Mobility definition is the ability of an electron to move through a metal or semiconductor in the presence of applied electric field is called electrons mobility. Electrons can freely move in comparison to holes. Therefore, mobility of electrons is more than mobility of the holes. It is mathematically written as Vn is equal to mu n E, or mu n is equal to Vn upon E. Vn is the drift velocity of electrons, mu n is the mobility of electrons, E is the applied electric field. Let us consider a semiconductor that consists of large number of free electrons. When there is no voltage or electric field applied across the semiconductor, the free electrons move randomly. However, when the voltage or electric field is applied across the semiconductor, each free electron starts to move more quickly in particular direction. Electrons move very fast in vacuum. Vacuum में electrons की speed ज़्यादा होती है. However, in metals and semiconductor, its speed is comparatively low or small. Free electrons do not move very fast. Instead, they move with a finite average velocity called drift velocity. Drift velocity is directly proportional to electric field. Hence, when the electric field increases, drift velocity also increases. The mobility of electrons is independent of applied electric field. That is, change in electric field does not change the mobility of the electrons. SI unit of the mobility is meter square per volt second. Hole mobility. The ability of an hole to move through a metal or semiconductor in the presence of applied electric field is called the hole mobility. It is written as Vp is equal to mu Pe, where Vp is the drift velocity of the holes, mu P is the mobility of holes, and E is the applied electric field. This is all about. Thank you.